Welcome to lesson 2 and 3 set problem. So we continue today. Today we are going to look at some terms that they can use to confuse us, or some terms that we can meet in examination room or maybe in solving questions. Right? These regions we have looked at already, but then we are looking at extra things about them. Now I have shaded region 1, region 2, region 3, which you've already seen that region 1 means Q only, region 2 means R only, region 3 means S only. Alright, now we have said that region 1 means Q only, region 2 means R only, region 3 means S only. So sometimes they can ask you to find the number of students who read only one subject. Now we can see that 1, 2, 3 are all about only one. Q is only, region 1 is only Q, that is only one subject. Region 2 is only R, that is only one subject. Region 3 is only S, so if it is subject, only one subject. So when you are told that find the number of students who read only one subject, meaning we are adding region 1 to region 2 to region 3, and that will give us only one subject. So region 1 plus region 2 plus region 3 should give us only one subject. There is another word they can use, which is exactly one subject. So how many students read only one subject? How many students read exactly one subject? Meaning add region 1, region 2 and region 3, and that should give you your answer. There are times too where you'll be told, as an example, 15 students read only one subject. Don't put 15 here, 15 here, 15 here. No. Put a letter here, say A. A letter here, say B. A letter here, say C. Right? Then when you are solving, you write A plus B plus C equals 15. You use it as an equation and then you solve. You don't have to write the 15 wherever you see. Right? So 15 students read only one subject, meaning region 1 plus region 2 plus region 3 should be equal to 15. So you are not supposed to put the 15 in all the 3 regions. No, you add them, then it becomes 15. So you first use letters to represent those regions, and then you equate to 15 when you are solving. All right, so what we have said is when you are asked to find only one subject, exactly one subject, those who play only one game, exactly one game, exactly meaning only, right? Exactly one, only one. So exactly one subject, only one subject, meaning pick the only one sides. Region 1 is only Q, region 2 is only R, region 3 is only S. So you pick them, then you add them. So assuming after solving, you had 2 in region 1, you had 3 in region 2, and then you had 4 in region 3. When you are asked to find those who read only one subject, it's going to be 2 plus 3 plus 4, which is going to be 9, meaning 9 students read only one subject or exactly one subject. Don't pick one side alone. Don't pick only region 1 and leave region 2 and 3. Don't pick only region 2 and leave region 3 and 1. If the question says find those who read only Q, meaning this is only Q, then that is the only side you take. Only R, this is the only side you take. Only S, this is the only side you take. But when the question says only one, it means pick all the ones and add them. So only one, that is region 1 plus region 2 plus region 3. Alright, so let's move on. Then we have this side too. We already saw in the previous lesson, or the first lesson, that where I find my 6, region 6, is known as Q intersection R intersection S complement, meaning region 6 means Q and R only, or both Q and R. So how many letters are we using? 2. So region 6 means only 2. Likewise, region 4 only 2, because R is not found in 4. So region 6 is Q and R only. Region 4 is Q and S only. In a like manner, region 5 is R and S only. So we can see region S is only 2 subjects. Region 4 is only 2 subjects. Region 5 is only 2 subjects. So sometimes they can ask you to find only 2. The first one we ask to find only 1. So we pick the size that represents only 1. We add them. So over here, because each one of them is only 2. Each one of them is only 2. If the question says find the number of students who read only 2 subjects, meaning you are going to take all the only 2 sides. So region 4 plus region 5 plus region 6, giving us only 2. Just like we said in only 1. We said only 1 is the same as exactly 1, meaning pick only that side. So the same way, only 2 means exactly 2. So exactly 2 means pick region 6, region 5, region 4, add them, and then what you get is the answer. So assuming the question says 17 students read only 2 subjects, meaning if you add region 4 to region 5 to region 6, you should get whatever value you have been given. Again, don't put, if the question said 2 students read only 3. Sorry, let me come again. 2 students read only 2. Don't put 3 here, 3 here, and 3 here. No. The question is saying 3 students read only 2. Meaning if you add region 4, region 5, and region 6, you are going to get 2. So use alphabet or variables to represent the regions. After that, in solving, you add those variables you use, and you equate to the given variable, or the given value. Here I said 2. All right, so that is it. Region 1 plus region 2 plus region 3 is only 1, or exactly 1. Region 4 plus region 6 plus region 5 should give us exactly 2, or only 2. All right. Then we have region 7, which we said it represents all the 3. So if the question says exactly 3, or only 3, we are looking for all the parts that are or all those who study 3 subjects, right? But we can see that from the Venn diagram, it is only one region that is found in all the 3 circles. So it's only region 7 which is found in all 3 circles, meaning region 7 alone is the part that reads only 3. So sometimes instead of saying find the number of students who read all the 3 subjects, they can tell you find the number of students who read only 3 subjects. Find the number of students who read exactly 3 subjects, meaning pick the part that is for all the 3, only the 3, right? So a quick recap on what we have done so far before we move on. Only 1, or exactly 1, meaning pick the size that represents only 1. Region 1, region 2, region 3. When you add them, what you get becomes your only 1, or exactly 1. Then we come to only 2, or exactly 2. Pick the size that are for only 2, or that are for exactly 2. Pick them, add them, and then it gives you your answer. Then we are saying when you are asked to find only 3 or exactly 3, that is the intersection of all region 7. All right, now I have this blank Venn diagram. That is to tell us something. Sometimes you can be asked to find at least 2. At least 2. We are saying that these sides are for only 1. These sides are for only 2. And then this side is for only 3. So if I am asked to find at least 2, meaning the minimum should be 2, that is, take those who read only 2 and then add them to those who read 3. Right? So at least 2. At least 2. So at least 2 means pick those who read 2 and above. At least 2, meaning the minimum should be 2. So those who read 2 and above, we have already established that all the parts I've written 2 are the sides that are for only 2. Right? So we pick those sides, we add them. But the question said at least 2, meaning 2 and above. So those who read 2, take them, and then take those who read 3. So after I've taken all the sides that read 2, I take the size for 3 as well, because it says at least 2. So 2 and above. But because you are dealing with only 3 sets, it's going to be 2 and 3. So I take 2 plus 2 plus 2, because all these regions are for 2 subjects, and then plus the 3, because that is for 3 subjects. The question said at least 2, so 2 and above. So you take the regions where they read 2, and then the regions where they read 3, you add them. You add them. So if the question says 17 students read at least 2, meaning you don't have to share the 17 for all of them. No. What you have to do is put alphabet here, say A, B, C, and D. But if you add them, you should get 17. So A plus B plus C plus D should be equal to 17. Then you solve. All right. There are times too where the question can say at most 2. At most 2, meaning the maximum should be 2. That is 2 and below. At most 2, 2 and below. So take those who are below 2 up to those who read 2. Those who read below 2 up to those who read 2. That is at most 2. The maximum should be 2, right? So at most 2 means the parts that read only 1. You pick all the parts that read only 1. Then you pick the parts that read 2. And that is going to be your, that's going to be your at most 2. Alright, so this is what I am saying here. So at most 2, meaning the maximum should be 2. So 2 and below. All those who read 2 subjects and then below or less than 2 subjects. That's going to be 1 and 2, at most 2, 1 and 2. So we pick all the sides that read 1. So the ones I've circled are the parts that read 1. Then we add them to all the sides that read 2. So 1 plus 1 plus 1 plus 2 plus 2 plus 2 is going to be those who read at most 2. It means we have to end at 2, at most 2. Alright, so assuming the question said at most 3, at most 3, meaning 3 and below, that is going to be everything 1 plus 1 plus 1, so that is 1. We get to all those who read 2, then we go to those who read 3, that is at most 3. At most 3. All right. Similarly, the question can say at least 1. At least 1. So the minimum should be 1. At least 1. The minimum should be 1. So that is going to be 1 and above. We are not given where we should end. So at least 1. Minimum is 1. So pick from 1 and above. Those who read 1 subject and above. So because you are talking about 3 sets, we pick for those who read 1 subject, those who read 2 subjects, and then those who read 3 subjects. At least 1. So it's like it is the same as at most 3. So at least 1. Pick those who read only 1. Pick those who read only 2. And then pick those who read 3. That is at least 1. 1 and above. And then it's the same as at most 3. That is 3 and below. All right. If I say at most 2, meaning 2 and below, which we have looked at already. Good. So that is how to identify these ones. Very, very simple. Right? Very simple. So we look at one example, then I give you a trial question which you will do it on your own, and then the last video on 3 sets I will address that, or I will answer that. Then I say a few things that we are supposed to know as well. All right, so this is it. Example 1. Okay, I should have made it just example because I have only one example. The second example is a trial question or a trial example. All right. In a town of 10,000 families, it was found that 40% families buy newspaper A, 20% families buy newspaper B, 10% families buy newspaper C, 5% families buy A and B, that is newspapers A and B, 3% buy B and C, and 4% buy A and C. If 2% families buy all the 3 newspapers, find A, the number of families which buy newspaper A only. B, the number of families which buy none of A, B, and C. Meaning there is a complement here. B is telling us that there is a complement. So we will look at how the diagram is done when there's a complement. You have to indicate the complement as well. Then C, the number of families which buy newspapers A and C but not B. So what we looked at in the previous video, we are going to look at how to apply it. The number of families which buy newspapers A and C but not B. D, the number of families which buy A and B only. And then the last question says the number of families which buy exactly 2 newspapers. All right, so write the question down, pause the video, write the question down as we move to the next slide. Now, before we move to the next slide, there is something I have to point out over here. The question has given us everything in percentage except the total number, which is the universal. If the question gives you everything in percentage and then it doesn't give you the universal, I'm repeating, if the question gives you everything in percentage but it doesn't give you the total, which is the universal set, then we are going to solve everything in percentage because total percentage is 100. So our universal will be 100%. If the question gives you everything in percentage and it doesn't give you the universal, meaning you are going to work everything in percentage because total percent is 100. So our universal is going to be 100%, and then we use it to solve without converting anything from percentage to another thing. The question gave us in percentage, it didn't give the universal, so we solve everything in percentage because the universal is going to be 100. Why? Total percent is 100, so universal will be 100%. And then there are times too the question will give you everything in percentage and give you the universal too to be 100%. That becomes simple. So also we are working in percentages. everything is going to be percentage. All right, but looking at this question, almost all of them are in percentage, but the universal is not. If the universal is not given and everything is in percentage, it means you are solving everything in percentage. They are trying to hide the universal because total percentage is always 100. Sometimes the universal will be given to be 100%, and then everything is also in percentage. You solve with percentage. But looking at this question, you have been given everything in percentage, but the universal is not in percentage. Whenever the universal is not in percentage, but then the remaining ones are in percentage, you use the universal to solve for each of the percentage. So you convert each of the percentages using the universal. So it says 40% families buy newspaper A. So we have to find the number of people who buy newspaper A, or over here family. So the number of families which buy newspaper A using the total given. The total is not in percentage, meaning we are not working in percentage. So whenever you realize that the universal is not in percentage or the total is not in percentage, it means we are not working in percentage. We only work in percentage if everything as well as the universal is in percentage, or the universal is not given and everything is in percentage, meaning the universal is going to be 100%. But if the question gives you everything in percentage, it doesn't give you the universal. Listen to this very well. If the question gives you everything in percentage, you were not given universal. We are saying you work with percentage. But there are times where the question will give you everything in percentage. It will not give you the universal, but then it will ask you to find the universal, meaning you are going to use a variable to represent the universal, and then you solve, converting the percentage using the variable you have used to represent the universal. That is very rare, okay? Mostly, they will not give you the universal, and then the questions will not be in percentage. But if they give you in percentage, mostly the question, they will not ask you to find universal. But in rare cases, they can try to convince and confuse you, right? And then even after solving, most of the times you are going to get 100%, because everything is in percentage. Universal should be 100%. But I said most of the times. There are times where they will try to trick you. So when percentage is given throughout, and then you are asked to find the total, make sure you don't just write 100%. Use a variable to represent, solve, and then you get your answer. I repeat, most of the times you get 100%. Sometimes you will not get. But if you are not asked to find universal, meaning universal is already 100%. All right. So over here, you have been given percentages throughout, but the universal is not percentage. So we solve each one of them. We convert each one of them using the total given. Good. So our data. So if it is not in percentage, say let U represent the total number of families. That is, number of U equals 10,000. Let A represent the number of families which buy newspaper A. Then number of A is equal to this. But then because you have been given percentages, we are supposed to convert them. So let U represent the total number of families. That is, number of U equals 10,000. Now we are saying A should represent number of families which buy newspaper A. Number of A is 40% of 10,000. Because you have been given the total number, the universal, we are supposed to find the percentage of it. So 40%, we know that 40% means 40 over 100. Sorry. We know that 40% means 40 over 100. So 40% of 10,000. In mathematics, we know of means times. So 40% of 10,000. that is 40 over 100 times 10,000. Then my 2 zeros here will cancel 2 zeros here. So I'm left with 40 times 100. So I have 40 times 100, right? And that should give us 4,000. All right, so 4,000 families buy newspaper A. So 4,000 families buy newspaper A. Okay. Similarly, B is representing the number of families which buy newspaper B, but it is also given in percentage. So 20% of 10,000, that is going to be 20%, which is 20 over 100, right, of 10,000. So these 2 zeros will cancel these 2 zeros. You are left with 20 times 100, which is going to be 2,000 families. 2,000 families. All right. Similarly, C is representing the number of families which buy newspaper C, which is also given in percentage. So 10% of 10,000. So 10% means 10 over 100 times 10,000, which is the total number of families that has been given. Right, so these 2 zeros again will cancel these 2 zeros. We are left with 10 times 100, which is going to be 1,000. 1, 2, 3. 1,000 families. All right. Then we go to number of families which buy newspapers A and B. So number of A intersection B, which is 5%. So 5 over 100 times 10,000, and that should give us, after these 2 zeros have cancelled these ones, we are going to get 5 times 100, which is going to be 500. So 500 families. So 500 families buy newspapers A and B. All right, then number of families which buy newspapers B and C, that is 3% of the total. So 3 over 100 times the total. All right, so 2 zeros will cancel 2 zeros. You are left with 3 times 100, which is 300 families. All right. So make sure you write the families in full because of the space. Good. And then number of families which buy newspapers A and C, that is number of A intersection C. None of them has only. So number of A intersection C, which is 4% of the total. So that should be equal to 4 over 100 times 10,000. All right. So these 2 zeros will cancel those 2 zeros, giving us 4 times 100. That is 400 families. All right. And then we have number of families which buy all 3 newspapers. Number of families which buy all 3 newspapers. So A intersection B intersection C, the intersection of all, that is 2% of the total. So that is going to be 2 over 100, that is 2% of, which is times our total 10,000. These 2 zeros cancel those 2 zeros. So we have 2 times 100, which is 200 families. So our intersection of all is going to be 200 families. Now, we were asked to find the number of families which buy newspaper A only, right? We were asked to find the number of families which buy newspaper A only. So I am saying let A represent the number of families which buy newspaper A only, right? So this one, because we don't know, we are not using fractions, so we are using just an alphabet. All right, there is one last thing I think I didn't indicate here. The question said we should find those who do not read any of them, the number of families which do not buy any of the 3 newspapers. That is number of A complement intersection B complement intersection C complement. All right, because we don't know, I want to use X to represent them. So number of A complement intersection B complement intersection C complement, that is the region outside, is equal to X, because the question said we should find those who didn't read, who didn't buy none of the newspapers, meaning we have complements which we don't know, so we use alphabets to represent. All right, so now this is my complement, because I said X should represent my complement. Then A only, which the question says I should find, so I use A to represent, is also here. These 2 sides I can use variables to represent or letters to represent, but because I was not asked to find, I can easily write the answer there, because I know when I add the whole of this circle, it should give me 1000. So if the whole circle should give me 1000, I know 200 plus 200 plus 200 giving me 500. It means those who buy newspaper C only should be 500. So when I add all of them, I get my 1000. All right, so I will write my 500 here straight away, because that the question did ask me to find that side. So in drawing my Venn diagram, I will write those answers straight away. So this one too, the question didn't ask me to find, so I can easily write it there. I know when I add the whole circle, I should get 2000. So if the whole circle should give me 2000, and I have 300 plus 200, which is 500, plus 100, which is 600, then I know that this side is going to give me 2000 minus the summation of these 3, which is 600, which is going to be 1400. So this side is going to be 1400. All right. Now I am looking for my A. So the question says I should find the number of students who read only this newspaper. Number of students who buy newspaper A only, which is where I've put my A. Newspaper A only. I know if I add this whole circle, it should give me 4000, right? So A plus 300 plus 200 plus another 200 should give me 4000, right? So A plus 300 plus 200 plus another 200 should give me 4000. 4,000. Right. All right, so let's move to the next slide and answer that. Okay, so number of families which buy newspaper A only, where we have put A. So we are saying A plus 300 plus 200 plus another 200 should be equated to the full circle, which is 4,000. Right, so 300 plus 200 is 500, plus 200 is 700. So we have A plus 700 should be equal to 4,000. So we group like terms and make it a subject. So we are going to get A equal to 400 minus 700. 400 minus 700 giving us 3,300. Not forgetting our unit, which is families. So 3,300 families buy newspaper A only. The families write it in full because of my space. Then the next question says number of families which buy none of the three. None of the three, that is the complement. So none of the three. So I know this. I know the remaining ones in all the circles, or I know the values in all the circles. I add all of them as well as the x, which is my complement. I equate to the total, because we know that everything in the rectangle should give us the total. In the previous lesson, we added everything in the circles and equated to the total because the complement was 0. So it means plus 0, right? So it's the same thing. So when we add everything in the rectangle, it should give us the total. But over here, the complement is not 0. We are looking for the complement. So we have to add everything and then we equate to the total given. So I should get A plus 300 plus 200 plus another 200 plus 100 plus 500 plus 1,400 should give me my total, which is 10,000. All right, so this is going to be a lot on our screen, but we will still do it. Okay, yes, good. I left 2 spaces for it. That is nice. So number of families which buy none of the 3 newspapers. So we are adding all of them. So A plus, you can refer from the Venn diagram, we can draw it and then you see what is happening. I'm adding everything, right? Everything. A plus 300 plus 200 plus 200 plus 100 plus 500 plus 1,400 equals 10,000. Yes, but we already know our A. We already know our A to be 3,300. So I will put 3,300 in place of A. So in place of A, I'll put my 3,300. All right. So we are adding everything here. Okay, adding everything here as well as the x. So we add everything without forgetting our x. So let me even bring the x first. So x plus our A, which is now 3,300 plus 200 plus another 200 plus 100 plus 500 plus 1,400 should be equated to the universal, the total, which is 10,000. All right, so if I add the whole of these things, 3,300 to 200 to another 200 to 100 to 500 to 1,400, that should give me 6,000. That should give me 6,000. So I have x plus 6,000 should be equated to the total, which is 10,000. Right now, I group like terms, I make x the subject, so x should be equal to 10,000 minus 6,000, which is going to be so we are making x the subject of group like terms, so x should be equal to 10,000 minus 6,000, but because of our space, we know right that 10,000 minus 6,000, which should be equal to 4,000 families. So 4,000 families by none of the three newspapers. None of the three newspapers. Then we go to C. It says find the number of families which buy newspaper A and C, but not B. Newspaper A and C, but not B. So let's go back to our Venn diagram. Newspaper A and C, but not B. So we take the B circle out, but not B. Okay, so we take the B circle out. So the whole of this is the B circle, right? We know that if the question had said newspapers A and C, it would have been this side. Newspapers A and C, it would have been this side. That is both A and C. But then the question said A and C, but not B. So if the whole of this side is newspaper A and C, and the question is saying but not B, meaning when we take the B circle out, that is, this side is going to go away, it's going to vanish, meaning we are left with 200, right? We are left with 200. So just like we said in the previous video, if you have but not, meaning we are adding only to it. So newspaper A and C but not B is the same as newspapers A and C only. Newspapers A and C only. So that is 200. So quickly let's write our C, which is going to be 200. So 200 families. All right. Then we go to, still on our diagram, the number of families which buy A and B only. A and B only. So it's the same as A and B but not C. So A and B only. Where is A and B? The whole of this side is A and B. But because the question has introduced only, meaning C should not be found in it, right? So A and three. What was that? It was 3,300. Okay. So A and B only is going to be this side alone because of the only. A and B only. That is 300. 100. All right, so we have 300 families buy newspapers A and B only. Then we go to our diagram again. The last question says we should find the number of families which buy exactly two So this is our exactly 1. We pick all the ones alone. Then this is our exactly 2. We pick all the 2 regions, and then we add them. So the same thing we are doing here, just application. So exactly 2. We are moving to our diagram. Okay, so exactly 2, which size do you think it will be? To be the regions that are for 2 only, the regions that buy only 2 newspapers, right? So it's going to be this side alone 300 plus this side alone 200 plus this side alone 100. So 300 plus 200 plus 100, that is exactly 2. So let's go quickly to that. So that is going to be 300 plus 200 plus 100, which will give us 600 families. So that is that. Now, assuming the question had said exactly 1, over here we don't have that, but assuming the question had said exactly 1, what would have been the answer? Let me go back to our Venn diagram, then you tell us the answer. Since I can't hear, which side do you think you add to get exactly 1? Yes, your guess was right. If you didn't get it, no problem. You can pause the video, or you can go back and then replay. So exactly 1, we are picking the size that are for only one. The parts that buy only, or the families that buy only 1 newspapers, or only 1 newspaper. So this is only 1, 3,300. This is only 1, 1,400. This is only 1, 500. So 3,300 plus 1,400 plus 500 should give us exactly 1, or only 1. All right, so our E we solved was exactly 2 newspapers. So we added this side, and that side, which is the same as only 2. Exactly 2, only 2. All right, so this brings us to the end of the lesson, but I have a trial example which we will look at. So this is the trial example. Pause the video, write it, solve it, and then in the next video, or the last part of the video on the 3-set problem, we are going to address that. Hope you'll be able to do that, and then you'll be able to solve this. And so I will address this in the last video on 3-set problem. Then I will address few other things you are supposed to know as well. So that video is also going to be a very short video, just like this. I will address this question, and then I will address 1 or 2 things as well. There are other important things we should know. He says, in a survey of 200 outpatients who reported at a hospital one day, it was found that 100 complained of malaria, 80 had toothache, and 50 were injured. All the 200 patients had one or other of these complaints, and 26 had exactly 2 of them. How many patients had all 3 complaints? All right, so that is the question. You pause it, you write, and then you try or answer it or address it in the next video. So we said the first thing, is to look for the full circles right over here, because we have looked at it in the previous video. That's why I just did that so that way you look for those ones. After that, you come to the intersection of all. After that, you come to these sides as well, right? And because if you know your intersection of all, it means you subtract it to get this side, and then that side. After that, you come to your only ones, and then you go. That is after you have brought your total, which is our universal. All right. So back to the question. It's a very nice question. Take your time and then try. In a survey of 200 outpatients who reported at a hospital one day, it was found that 100 complained of malaria, 80 had toothache, and 50 were injured. All the 200 patients had one or other of these complaints. All the 200 patients had one, or we should have continued, but no problem. Other of these complaints, meaning our region 8, our complement is 0, no complement. All right. And 26 had exactly 2 of them. I've addressed that. 26 had exactly 2 of them. I addressed it over here, where I use 0 to shade. Sorry, I use yellow to shade. I addressed that where I use yellow to shade. That was this side. We said exactly 2 over here. And then I said, example, sometimes they will tell you 15 students read exactly 2 subjects. It doesn't mean put 15 in all these 3 regions. No, it means put alphabets there. When you are done, add them and equate to 15. That is when you are solving, and then you will get the answer. So I'm giving a clue to the trial question. So 26 had exactly 2 of them. 26 had exactly 2 of them, meaning use alphabet or variables to represent the exactly 2, right? That is the only 2. And then when you are done, you add them, you equate to 26. And then the question says, how many patients had all 3 complaints? Okay, so that brings us to the end of today's lesson. Thank you for your time, and then all the best. Fine, we will address the last video. We address the last part of this lesson, and then that will be all for 3 sets problem. If you have anything, let me know. If you have anything I have to address, let me know. All the best.